Today I'm going to explain a vector question, which is a question from Baulkham High School 2021, Extension 2 Maths, Task 3. The last question, question 8b. A diagram is given. OABC is a parallelogram to adjacent vector A and C. The angle between is alpha. The magnitude ratio of the two vectors is 1 to 2. Not in scale. M is a point on AB, such as vector AM is equal to K8b, where K is in the interval between 0 and 1. Angle OMC is a 90 degree. This is the most important information. Part 1 question. Use a vector method to show this equation in terms of variable of A, K, and alpha. 90 degree gives the clue that dot product should be used. So we start with the dot product to vector OM and MC because the angle is 90 degree. Vector OM is equal to OA plus AM. Two different paths, but they start at the same point O and finish at the same endpoint M. So they are equal vectors. For vector MC, it's equal to MB plus BC. Both start from point M and endpoint is C. AM is a K8b, that's a given. So MB will be 1 minus K8b because AM plus MB is equal to AB. AB is the same vector as a vector C because they are the opposite side of a parallelogram and in the same direction. BC is a parallel to OA but in opposite direction. So here is a negative vector A. Then apply distributive law to expand the brackets. And next combine the two like terms of vector A dot vector C for the first and the last term. Dot product is a scalar product. So vector A dot vector C is the magnitude of A and magnitude of C and cosine alpha. Vector A dot vector A is equal to magnitude of vector A squared, and same to vector C here. Checking equation of required to prove, there's no vector C. Thus, magnitude of vector C should be substituted by 2 times of magnitude of vector A. Here is a 4 because the square. For a short question, better to keep eyes comparing your workout to the required to prove equation, which will give some clue what you need to do and what you may get. The required to prove equation has a factor of 1 minus 2k for cosine, which is matching to what we have got. So I will leave the first term untouched. But the second part has another factor of 1 minus 2k. So it indicates that we need to combine the last two terms and hope to get 1 minus 2k squared. Actually, it does. The last step is to take the common factor magnitude of vector A squared and 1 minus 2k. Then we get this equation as a required. Now let's see the second part. The question is to find the values of alpha, such as there are two possible positions of M, satisfying all the given conditions. The keyword here is two positions for M. For sure, we should start by using part 1 equation. The equation is a quadratic equation in regard to variable k, but having two other variables, A and alpha as well. It has already in factorized form, so either the first factor or the second factor to be 0. Magnitude of a squared is a constant, so no need to vary it. The first one give k is equal 1 or 2, no alpha value. That means when k is 1 or 2, there's always one position for m, which gives the 90-degree angle, no matter whatever the alpha value is. The second equation has a variable alpha and k. In order to using the inequality of k, we should write k in subject, rearrange, and get cosine is between negative 1 on 2 and positive 1 on 2. Be aware that when divide or multiply a negative number to an inequality, the inequality symbol need to be reversed. Thus, less than or equal to is changed to greater than or equal to. Because cosine is decreasing function between the interval of 0 to 180 degree, the alpha value for the second point of m are from 60 degree to 120 degrees and inclusive. Or another method is to substitute k with the boundary value of 0 and 1 to equation 2. When k is 0, alpha is 60 degree. Sub k by 1, the alpha is 120 degrees. This also gives the range of 60 to 120. This method is less confusing compared to the first one. But this is not the end. We need to verify k is 1 or 2 because from equation 1, 1 and 2 has already been one position for point m. And the second position from equation 2, we're using the interval of k from 0 to 1, which also include 1 and 2. So 1 and 2 will be a repeat solution. Substitute k by 1 and 2, and find alpha is a 90 degree. And 90 degree is between 60 to 120, so 90 degree should be excluded. Now, this question is done. But what does this vector question geometrically mean? I made a scale diagram for visualizing this vector question. First, let's see the case when point M is on the midpoint of AB, that is k equal 1 or 2. Construct a vector from the midpoint of OC to midpoint M. It divides the big parallelogram into two equal size parallelograms, with all sides have an equal length as a vector A. Because the long side of vector C magnitude is twice of the short side of vector A. Hence, a circle can be constructed by going through these 3 points, O, C, M. OC is the diameter, and the construction vector is the radial vector. Now you can easily understand why angle OMC is a 90 degree, because it is the angle in a semicircle, subtended by the diameter, so it is 90 degrees. This is the property of circle. As the alpha change from 0 to 360 degrees, the midpoint M just run along the construction circle. So k equal 1 or 2 is a solution for point M, which is independent from angle alpha. The special case when alpha is 90 degree, the parallelogram become a rectangle. In this case, the side AB is tangent to the construction circle. Thus, only one solution for point M, which is a repeat solution. Next, I demonstrate the second point of M, when alpha is between 60 degree to 120 degrees. When alpha is 60 degree, the second point M gives 90 degree when it's overlapped with A, point A. That is k equal 0 because AM length now is 0. When alpha is increased to 120 degrees, the point M gives the 90 degree when it's overlapped with point B. That is k equal 1 because AM is the same length as AB now. So for each alpha angle, it's between 60 degree to 120 degree, not including 90 degrees. There are two positions of point M, which angle OMC is 90 degrees. I think you may interest to know that for those have been one position M situation. Actually, there are second position for M having 90 degrees, but it's outside of the line AB segment. It is extension. Thus, K value is outside of 0 to 1, so not satisfying the question requirement. This is the end of this video, and I hope my video is useful for your HSC mathematics study. Thanks for watching.